How's it going, everyone? Welcome, Eulier Gonzalez here. Let's go to now jump hop into the point-free techniques, which is a concept that allows to make our code provable, aka readable. Now, this is a course taught by Kyle Simpson, and I'm going to make a quick recap of how do we get here by exploring this particularly topics. So bear with me, and there you got it. Which is at least this 4.1. So introduction, function, period, argument, adapters, and pointer. Now the TLDR of this course is to see how we can use all of these concepts from functional programming and understand the benefit of applying these techniques and what is the value proposition at the end of the day. Because since most of the time our code is in an imperative way, which is we tell the machine exactly what to do and how it's going to do all of that kind of stuff that we want to. Now, the problem is that if another developer get in here and try to read that or understand that, it won't do that at a glance. Now, to try to understand or the value proposition of the functional programming is that by being declarative, one, and relying on mathematical proof, pretty much like when you go out into a restaurant for a dinner with a girl, all right, or a guy, and when you need to split the bill, I'm not a guy of 50-50, I'm 100% guy, so anyway. But if you want to split the bills, so you don't need the mathematical proof of saying, hey, you know what it'll be is 2 plus 2. I need to know that before going on. I need to understand what the arithmetic here. Addition, subtraction, and multiplication and division. No. You don't need any of that. You just know what is the input and the output that get out of it, which is 4. 2 plus 2, 4. So you receive the bill. You know, okay, this is all of the stuff that we buy. Sometimes not. Sometimes we buy stuff that we don't need to. Most of the time. But at the end of the bill, right, the bottom line, you look at that and say, oh, now it makes sense. Okay, so this is, now we're going to split this stuff. So that's exactly that. And we also do this unconsciously because since we rely on this mathematical proof or tools, for example, when you go out into a restaurant or when you buy and sell stuff, so, because you don't need to think the mathematical underground of that, you just only use that tool. You just relying on that tool works, does what it does, and this is exactly the value proposition of the functional programming, at least in JavaScript. And this is a book called Functional Like JavaScript, which is by using all of these concepts and techniques, we're going to now, and we're going to answer a question, right? And that is, wouldn't it be nice to have sections of our code that we know that for sure they're going to work as expected, so we can focus on things that we don't have that confident. For example, business logic that are constantly changed. Now, this is the entire value proposition of this, of functional programming. So we're going to rely on things that are provable, that we don't need to think pretty much like when you go out to a restaurant or we just need to split the bill, you don't need the mathematical proof, you just only apply them to get an outcome. So I find out this is very enlightening, especially because now I can, also I'm working for a company, right? A Chilean bank that we actually are building these kind of interfaces in React Native for their particular product, that now, since we need to develop all of this user interface, all of these functions to render specific UI elements, it makes a lot of sense to understand how the things work and the value proposition of that. This is great. This is good. So because we are unlike what was the name of that square root? Square root. I think it is. Square root. I'm gonna say that in Spanish because I learned in Spanish. Jesus, 8th grade formulas. I don't recall that. Perhaps Khan Academy can help us here. Khan Academy can help us here. 8K grade can right. The math that you learn in kindergarten all the way up to the math you learn in 8th grade is very important. It's very important in real life situations. Without that, you wouldn't be able not to live through life easily. 8th grade, where you used to learn pre-algebra. Exactly. The picture of the right is known of the world of math, but yeah, it's Jesus. Pre-algebra. Okay, now why not, man? Do us to help us here. Kindergarten, 2nd grade, 3rd, 4th, 5, 8th grade. Okay, math model foundations. There's a lot of foundation here. I know I'm taking quite a lot of time here for this, but it's just to understand this in a way, complement area verticals. It's just to recap, some of the. Oh, but this is 8. I'm telling you, this is. 8th grade. Number operations, solving equation with a known linear equation, system of equation, data modeling. I think solving equation with one unknown. Solving equation with one linear equation and functions. Linear equations or functions. System equation. Linear equations. Linear equations. Okay, linear equations formula. Let me see if this one. Okay. Yeah, something like this. Again, I mentioned this is because there are some particular formulas that allow you, for example, point slope and point gradient. So the thing here is that by relying on this particular formula to get something. So for example, if you want to draw a line that is exactly, if you want to draw a line, you have this particular formula. Yeah, if you want to draw a line, you just do this or do this. This is the formula. If you want to get is the square, I think that is the quadratic. Oh, come on, really? I closed all of them. Okay. If I want to go with the quadratic here, formula. So is this one? So you now can see how you can. This is the formula. This is the formula that I was looking for. The quadratic formula. Okay. So again, you have now this mathematical proof that if you want to know how the things work, yada yada yada, you can dive deep into it. But if you only care about how this look like, okay, what is the outcome that you get from, is this one. All right. So most of the time, as a functional programming, that's what we really care about, is what is the shape of this function and what is the outcome from that. So I'm glad that I recall that, despite that English is not my main language, but it works across the mathematics is universal language, which is a good stuff. So be for or to look at all of these particular tools, we need to explore about function purity, arguments adapter, and point free. I'm going to make a quick recap of this, which means is that unlike procedures, functions must. So function described is the relationship between, the semantic relationship between the inputs and its outputs, all right, and the inputs, the semantic relation between the inputs and the computed outputs, and to get the benefit of that this function will work as expected, we need to reduce the surface of reassignment, aka the side effects, or aka anything that modifies the state of the programs outside of the function scope. And that is network calls, database calls, DOM operations, timestamp, random numbers, or anything, ultimately anything that generates CPU heat or CPU time delayed is something that you want to extract from that functions. So how you can extract that? Well, there's several techniques that we can use on the functional programming. One of them is, containing the lexical scope and return a new copy of that, which is what most of the time we work as the JavaScript developers. And the other is a brute force. The first technique, calling or containing the lexical scope, as long as you have access to define the function definition, great. If you're not, all right, then you need to use the brute force, which say, hey, let me take a snapshot of everything, and by the time I call that function, which of course is gonna perform some side effects, then I want to restore the state afterwards and return the new state. So there is some exercise that I made that was quite interesting and quite useful. This is called as function purity. All right, and the TLDR of this is that we're going to increase the level of confidence that we have in our code base. So that's a great stuff, because we can focus our attention on stuff that we are not that confident. Most of the time, side effects, business logic. So we look also another topic, which is something that is relevant from the functional programming POV, because they are obsessed is trying to understand where all of this come from. They are obsessed with the shape of the function. They call this the type signature. So to make it easy to explain, which is just a fancy word or a fancy expression to say, hey, I want to know is the number or the number and the shape of things that we're going to pass to these functions, and the number and shape of the stuff that come out of this. So this is the shape of the function, the type signature. And there are some quiet concepts to actually get familiar and be on the same page with them, like arguments and parameters. So parameters are from the function's definition point of view, are those name inputs, and the arguments are the value that you pass here. And what we care in this function programming is that any time that you call a function, you have now that high level of confidence that that function behave in a pure way, in a provable way. All right, so the argument adapter is just to recognize that since functional programmers are obsessed on how all of these different piece of Lego blocks works, by looking at the arguments of the function. So the most favorite functions are unity, and the second most favorite are binary. And how by creating this higher order function, which is a function that takes a function, or it can return a functions, we can now create these adapters, these higher order functions that allow us to, for example, transform the arguments. Okay, so if a function that you receive has a lot of arguments, you can now only say, hey, I want to take the one, which is unity or binary, or even you can flip the arguments here. All right. And I'm mentioning all of this because functional programming is like when you put on special sunglasses that you are able to see and examine and to identify all of this kind of stuff. So if you hit the gym, or if you go to do boxing, or if you do any other activity outside, even playing games, you now develop, by being exposed to that activity, some sort of knowledge, some sort of mindsets, sunglasses. And that's quite interesting. All right. But that is the arguments adapter, okay? And how you can create these arguments, or how you can create even your own higher order functions for these argument adapters, and why this is not advisable, despite that you might have your great idea, is that because we are not, as a community, we are not familiar with so familiarity is something that is very helpful for that. In other words, the more you expose to that, the better off will be. So what does it mean is you are going to get yourself familiar with all of these functional programming libraries to see how that works and what is the benefit of it. So if you somehow find yourself creating your own higher order functions or utility functions, you can now make a PR suggestions and then push those changes to that library. So the deal there is that we look at now how we can create our own higher order functions to actually play with the arguments, to actually now give a shape of the arguments of our function, right? So you have now unity, binary, flip, so you can flip the first and the second arguments, right? Or perhaps you want to reverse that, or you want to apply, which is that given this array of arguments, I want to now, or given this comma separate value of arguments, I want you to now apply them into an array, right? So that's what we have, for example, in functions, JavaScript methods, stuff like call and apply and bind, right? So a call is, well, I'm going to call this function with all of these comma separate arguments, value, comma separate arguments, or an apply that you're going to receive this as a collection of values as an array, and then behind the scene is going to get each one of them independently. So this is a good stuff, because we are also looking at the functional aspect of this in JavaScript, and how it actually you're starting to see the roots of the language. Another important topic to talk about is the point free, and how now point free is something that increases the readability in our code, but also if you're not familiar with that, it tanks the readability vastly. So that's when you start to see that's when now, yeah, the readability decline vastly. Because what am I buying here with the point free? So you remember now point free, which is in 8th grades when you have now your equations, all right, in x in y and g, in y and x axis, and if for some reason you want to now say, hey, I want to fix here, I have a functions, okay, where I want to draw something here. You have the x and g, so I want to fix is the y position phi, all right, and then I want to now see what are all the values at that. So you eventually creating is a line. So why am I bringing here this in functions? So if you want to now as from the shape perspective, all right, it's important here. So from the shape perspective, if you say that this function has the same arguments, all right, you can now describe another function that has the same shape, all right, the same arguments. You can say, all right, now let's actually write that without describing the data points, without describing its arguments, because at the end of the day they have the same shape. And this is what point free actually is now doing this. So this stuff, okay, is called equational reasoning. This is not equal reasoning, this is equational in terms of its shape. So why am I buying this? Why are we buying here with this? And that is what we are actually looking in today's video, okay, by exploring is that now it makes quite a little bit sense. So if we look at, let me actually change this and say, hey, I want to now show is the functional light. Oh. Functional light, that's right. So I want to go to the code, all right, and we're gonna do this particular exercise here. Oh no. So instruction: refactor the output, print if and is long enough functions to use point free style. Hint: some browsers require console log to run against the console log context. So f is equal to console log. So if f failed because of the loss of this binding, use bind to be safe. Print if you can express in terms of a when that look like. Okay. Print if can be expressed in terms of when of a when that look like this. So as you can see, this is a higher order function. Okay. All of this might be quite annoying to read, but the thing here is okay. But the thing here is that when you call that function that is receiving a function, and that functions, and we're going to call another functions, but this time is with the predicate, okay? And now we want us to get is the arguments of that, which is a global variable that you can have access to actually get is the arguments of all of the functions. And we want to actually dive deep into this because to me it's quite interesting. It's like we are assuming that we have this argument, okay? And the question is that by the time that we get here, what is the argument shape of this? All right? Is function and predicates, or is the value that are receiving here? You know, that's a good question. Well, follow me here. I'm gonna ask Claude here. I am learning point freestyle functional programming, right? Functional programming. Yep, I'm learning point freestyle functional programming. So based on the following question, on the following code, is this. Really? Okay, you wanna do this? Alright. Chill, bro. Okay. Jesus. Oh my God. Okay. Okay. What will be the value of args? Is using the rest parameter syntax, which means it will capture all the argument passed to the innermost function as an array. That's another interesting stuff. Is capturing. So the arg parameter is when in your when function is using the rest parameter syntax, which means it will capture all arguments passed to the innermost function as an array. Okay. So in other words, is that when we call this, it's gonna capture is, you provide a function to when this return a new function that takes a predicate. The return yet another function here. The return yet another function that has set any argument, any number of arguments capture as arg. Inside this innermost function, both predicate and functions are called with the same argument. Okay. When double is even. It has, okay. So in the last example, R will be the array here. R will be 4, R will be 3. is the last value here. Of course, you call that double if even. The rest parameter syntax allows the function to handle any number of argument flexibility. This pattern is common in point-free style programming, and it also allows you to compose functionally without explicitly naming the parameter in each step. So you don't need to express, or you don't need to call the parameter in each step. So, in other words, by doing is this, but why? So in other words, by doing is this, you initially are passing is exactly. So we initially are passing. Okay. So we initially are saying, hey, this function's definition, I'm gonna receive a function that is going to return a new function, and here we are creating a closure. Okay, which is a great, powerful tool in JavaScript to save the lexical scope of that. Again, something we're gonna look at that later. But yeah, this is function predicates, okay, as a second argument, but as a second time you call that function with a value called predicate, all right? And then you say, hey, I want you to give me all of the arguments, and if the predicate, which is this particular function, if the predicate computes all of this, all right, if you get any value from this, if this value is true, all right, once you compute that, okay, then I want you to compute is the function. This is pretty much like guard. What you're doing here is some sort of guard here. It's like, hey, if the predicate work with this, then I want you to now work with the main function. So in other words, by saying is this, the first time you pass is double, and then it's even, and it say, hey, is even here. Is this argument even by the time that it passed through this, and you call this with this value, is going to check now the predicate and say, hey, what is the predicate function? It's even. It's gonna call is even. It's gonna do the mathematical computation here. All right. So we are now being more descriptive about what it's going to look like in English term, in plain English. All right. And if that is true, all right, okay, then I want you to apply is the first function, the double function. Double if even. Double if even. Args will be 3. Args will be 4. Double if even. Interesting. So, in other words, the expected output here. Oh, come on. In other words, the expected output here. For example, if even 4 is gonna double that. You're gonna say, hey, yeah, I'm gonna apply this function, and I'm going to print out 8. 3, no. Double if even, I'm gonna say 20. I'm gonna say yeah, 20, 40, and 60. Oh, because when is not defined. You are right. Oh, come on. Clear the console. And then you do is this. Instead we say double is even 8. If you say 7 or 3 is undefined because it's not computing that, it's never getting there, and if one of their argument it is, then it's going to compute that, which is 20, 10 or 20 and that kind of stuff. What am I buying here? Readability. That's all. Readability, baby. Readability. So we're gonna make a quick pause here, and we're back. All right, we are in a different setup, as you can see. I just paused the video to actually make that quick recap of how do we get here, and well, let's go to now explore the point free technique. So let's get into this, because at the end of the day, point free technique is just a tool that functional programmers use as a way to improve the code readability. All right, so since now by using is pretty much like when you go and this is something that I'd already make a quick recap, but by recap what you look or you learn at 8th grade in your math class, when you have now the Cartesian graph, so you can draw is any figure that you can imagine, but you have now two axes. You have the y and x axis, and when you fix the point, for example, of one axis, and then you can draw is a line in that direction, right? In that dimension. So the thing here is that because we have now this point, or the way of how you can fix parameters, okay? So in the context of function is like this will serve you, this will help us to say, wouldn't be nice to answer the question, wouldn't be nice that if the shape of the function is the same, we can describe that in terms of okay. We can describe that in terms, sorry, I make a yeah, I take a segue in my mind, but in any case, the idea here is that wouldn't be nice to if two functions, you can think of this as Lego block, have the same shape, wouldn't be nice to only just describe in terms of the function without actually invoking that in JavaScript, without actually calling that. So, which is what we're looking here at point 3, right? So for example, if you need to, if the shape of the function, which is the argument, so what are the number of things and the shape of it, as well as the number of things and the shape of stuff that comes out of this, in this case like this, all right, if they have the same shape, function shape, type signature, well, we can rewrite this in terms of only their in terms of on the labels, their identifiers, their function name, the relationship, because here you might, this is also something that I answered previously here with the value proposition of at least a 0.3, where what are we buying here is to see the relationship of how this function works more clearly. So for example, here you say, hey, get person and gonna pass is a function called render person, right? So whatever this function is, all right, you know that you are going to get this particular data as it is. So this is known as equational reasoning in terms of its shape, not in terms of its values or arguments. It's in terms of its shape. It's equational reasoning, equation in terms of its shape. So that's what I put here, in terms of its shape. So because of that, and that's why we look at this particular tool that come from functional programming libraries like the Lambda, right? So the idea here is to make those computations, make the computation relationship more easy to read, all right, by relying, of course, on mathematical principles. So because this might be something quite arcane to understand, especially for those who are not that quite familiar to the language, all right, but at some point you will need to understand this, all right? But you can quickly imagine that if this is a computation, all right, that is a pure function, okay, or even though if that now has some side effects, and by the time that you call this is odd function, it has now the by when you call that function, you will know that that function get what you need without affecting the overall state of the application, all right? So it seems that, hey, this is odd, right? Cool, pretty cool of this. And we can clearly see the relationship of this. So instead of actually is doing this kind of stuff, all right, and you can see, hey, it's even like this. You say, yeah, of course, this is pretty straightforward, but you need to create this function. The point of this is to say, hey, I would like you to create now a function, a high order function wrapper with that functionality, and then provide some sort of semantic, some sort of computed output, which is a fancy say to say, hey, I'm going to create now this not function that is which is a high order function. You're gonna take these functions and then it's gonna return is something, all right, in this case the negate of that function with this argument. So the idea of point 3 is to increase the reliability, increase the relationship between these functions. So here I'm passing is now the not and is odd, and you can clearly say it's like, oh, okay, now this is even. There is also an exercise here that I want to go to. Okay, let's move on here. This is now enterprise UI functional IDS. Exactly. So yeah. So we got now this a couple of instructions here. Let me actually zoom in a little bit. And you got it. Okay, so here is this. So point 3, this is an exercise to practice point 3 style. So instructions: refactor the output, bring if and is long enough functions to use point 3 style. There is a cautionary tale here, because this is when now the readability of your code start to tanks. When it started to decrease that. So as long as you're quite familiar with this, and that's why we look at other videos about the argument adapters and the functions, and what is the function purity and the difference between a procedure, to understand all of these concepts. All right, so we check. So once we are here, we are now and we are quite familiar to develop this instance when we started to write our functional application. So it's like pretty much putting some glasses here, some special glasses, so you can evaluate this. Because we want to refactor its output printf and it's long enough, okay, to be point-free style. There's some couple hints. Some browsers require console log to run against the console log context. So if f is a console log, the f fails because the loss of this binding. So again, this is part of how the host environment of the JavaScript actually provide this set of API, because at the end of the day, console log is not from JavaScript. It's provided by the host environment, whether it's the browser or the server, in the case of Node. And that's why we need to use bind to be safe. Okay, makes sense. Oh crap. Okay. So the other is printf. It can be expressed in terms of when. That looks like this. So when you get that function and then you call that function again with the predicates, and you call that function again with the arguments, then you're going to check if the predicate or that function that you receive here, I would like to say that this is the predicate function, predicate function, predicate, but in any case, so once you evaluate is a predicate, because at the end of the day this is a function, that's why I would like to say something like this. So predicate function. Okay, that's why I prefer to say something like this, because even though that here is quite explicit, but we are receiving is a function's reference at the end of the day. That's why I prefer to look at this kind of stuff. All right. So yeah, when f is this, return function predicate fn. So once you now receive the predicate function and the arguments, now it is time to evaluate by the time that you create a new instance of that, it is time to evaluate that so you can use it. So actually, let's get into this. It's like, the TLDR, bro, the TLDR. So this is something that we can express in this form. This is in a point-free style. Let's try. And then you say, hey, I would like you to define this in terms of cons, that you can redeclare or reassign the value of this identifier, which is, I'm going to call it here output. Okay. And I want to define this as a point-free style, which is this is a function that I want to now console log dot bind, so it doesn't lose the context of which file we are querying, and this is it. Pretty much this is it. I want you to return is now the console, and yeah, you need to get some sort of text for that. Okay. You need to get some sort of text of that. So by the time you get that text, I will also love to pass is the argument, which will be text, right? There you got it. So this in theory is supposed to work. Let's get into this. This in theory is supposed to work. Come on. To work. Okay, you got it. clear, and then you say, hey, no, I want you to run is node point free here, and then say, hey, the exercise.js, it say, hey, this is it's a console console.log .bind, there you go. It's not a function, right? So by the time you do this, you say, hey, this is not a function, console. You didn't update that. It's like you didn't update that. Yeah, you didn't update that. Okay. What about now? Oh, okay. It runs. It runs, but That's why I'm putting in practice this, because what I'm saying here is that I want to rewrite this function as a point free. All right. So in other words, if I'm going to use now the output by taking that message, okay, we're going to receive that. I want to console log that, right? Which is quite interesting. So if I go back to this, and then I say, hey, you know what? Please uncomment this, and then go to this. Okay. No problem, bro. No problem. No problemo. No problemo. Functional light, yes, point free. It's because we are returning is another function, and that's not what we want. Exactly, it's because here we're returning is another function, and I don't want to return is another function. In fact, what you do is execute this. So if I say this, it doesn't. No problem. What is the problem here? That I don't know what I'm doing. Okay, and I want to rewrite this function as a point free style. All right. So what is the pattern here? You can create some sort of high order function to wrap this. Okay. Yeah, you can create some sort of wrapper functions to transform this. Okay. And you call that, right? So what I'm doing here is I say, hey, I want to store is this, all right, output, and by the time that I pass this, okay, point free, Jesus, So what I'm doing here is to say, okay, this function, okay, I'm assigning this label called output that will now is call this function, and because now console log has the same shape, all right. Okay, and because now because output has the same shape as a console log, then I can use this. So far, so good, right? The other is transform is long enough function to use point free. Is long enough. Is long enough. It's another one that you can say, hey, is long enough. You say, hey, it's going to define is a count that cannot be redesigned or redeclared, and then I want to say in a point free style, which is sure enough, all right, and I'm calling that with the and I'm calling this with the arguments that I'm passing here, okay, is long enough, is sure enough, and I can say it's this, all right, because functions are hoisted. So if I'm doing this, what I'm saying is, hey, I want to now this function that has the same shape, and by the time that I call is long enough and pass this argument, you should now is wrong is sure with the negated, right? And say that. Exactly, because they are not hoisted. Should bring on. Wait, what? Should bring it. Okay. So this actually works because they have the same shape. Okay, and what I'm doing is just calling this, and by the time that you call this function, this is the argument that you're going to receive. However, here, since this is a function, okay, that I'm not going to pass any argument, but I can create now a high order function. I can create a high order functions to actually is define that, right? You can say is, because I'm doing is just the pattern, just repeating this the pattern here. You say, hey, not, this will be is a function, all right, and this function not, by the time that we call again, what we're going to receive is the here we're receiving is a function, here we're receiving is the argument, okay, and you say, hey, the argument, you say args, all right, and when you receive those args, I want to now is say something like this. I want you to return is the negations of this, whatever function with this argument that you're going to pass here, okay, I want you to negate it. So you can say something like this. You can say, hey, because I'm calling not and I'm passing is this function, all right, and by the time that you call that is long enough, all right, not is short enough. So by the time that you call is long enough here, so you're assigning is now the first invocation here. So by the time that you call is long enough and you pass some arguments to that, that must tell you is this. Okay, this might not be quite clear to me, the relationship. I mean, I'm just copying stuff here. I'm kind of knowing what's going on with point 3. And the other is mind bending this. And the other is mind bending because here we need to create is another high order function. All right. Here we need to create is another high order function, but in this time it's called when. That it say, hey, I want to transform is print if. Okay. I want to transform is print if. And it say, hey, when you receive the first function and the predicate of that function along with its arguments, okay, that's why you need to define here like functions, bro. That's why you need to define it as function. But in other words, you are now getting is this. That's why type annotation is important. You know, it's like, man, that's why type annotation here is important. That's why type signatures is so important, especially when you have all of these kind of labels, because you can quickly lose yourself. Oh yeah, you can, bro. Oh yeah, you can, bro. You can quickly lose yourself, bro. That's what. You can definitely quickly lose yourself, bro. F. Pay F to show respect. Press F to show respect. Okay, now the stuff from grow up people. Oh crap, you got it. Yep. All right. So now the stuff. All right. Now this is the thing of big boys and big girls, right? Big boys. The big boys. Okay. let's go into exactly. Let's go into let's go into now is create is a high order. So why are we creating is this high order function? It's because as long as they have the same shape, we can describe is the relationship much clearer as we can see here, right? So it's long enough, it is equal to none is short enough. And this is when TypeScript kicks in and say, hey, you know what? You need this. So what is the relationship that we want to create here? Print if. Okay, so this is the relationship that we want to create here, okay, which is holy bro. So we're going to receive that property here, okay, and by the time that we call this function with the message, we say, hey, should print it message. It's like the predicate. Okay, so here we are going to create is this high order function. Here we're going to create this high order function printf to say, hey, first you're going to receive is now the predicate along with its argument, and then you're going to now call that if it is. So in other words, you say, I was going to create now this function, say, hey, when, all right, when, again, here we are now describing as a semantic relationship of this. So when we call this function, and that is the function, okay, so when we call this function, we want to now return is another function, or another call. In other words, we want to call, invoke another function that will contain is the predicate, okay, which is the, in our case, is the condition, the statements, the predicate that we want to check, all right, and once you get both of them, once you get the function and the condition or the predicate, all right, here's when we're going to now call these functions to receive the arguments, all right, the arguments that we're going to evaluate, all right, and then we say, hey, if the predicate with the argument here, because the relationship is this, should print, which is this. If the predicate is this, then I want you to return is now, so if this predicate with this value is true, okay, it fulfilled that, all right, I want you to call the function with those arguments. But I think because I'm passing here just a single argument, so I don't think it will work. In fact, you have to say, hey, this is print if. But I don't think it'll work because you are not passing is all of these arguments here. Because printf is saying, hey, the first is the function is short enough, okay, and then you have is the predicate, and then you're going to receive is the argument as it is. Then you're gonna pass those arguments to that. Again, this argument, it is close to this, but it's because argument is now is a property from the function. It's a property from the function declaration, not arrow function. They don't have is the arguments and all that kind of stuff. It's function declaration, you know. So functions declaration. Pre-declaration, but you have is hoisted. No. Where is it, man? The function object. I'm looking for the function object. Exactly. The property in the instance and the instance property. The function dot prototype arguments. Deprecated, not a standard. Okay. And static methods. In static properties. And the instance. Display name, length, name, prototype. No, I get it. No, I get it. It may click, bro. It may click. Okay, it did. So so give me all of the arguments here. And pass is these arguments as it is. It's not calling it because first you say, hey, bring if, and say, oh, exactly. So if the first parameter, if the function bring if, okay, call bring if, where you're gonna pass is the first argument is a function, and you want to write this in this way. All right, so what I'm trying to do here is to say, hey, print if, or trying to say something like this. When you get this function with the predicate and the function, you're going to do that. So in other words, it's like say, hey, when you call now print if, Okay, print if, because what we're doing is just redefining this in terms of a point free style. So print if will be now is when that function shape where I saying is the output. Okay, so when the output, which is the function that I'm passing here, in the so when I call the function output and say is short enough, in our case, because we're passing is the value, is short enough. All right. So when we call this by passing is output, and the second time is passing is a predicate. All right. So when we call printf a third time, we're going to pass is the argument. So now we can say, hey, there's no need to say printf here. Is short enough or is message. You just only do is this, right? And that will work. Holy fuck. When output, okay, so when output, all right, that this will return you a new function, and that will function will say, hey, I'm going to reserve is this identifier called printf that I'm going to pass now is the predicate and the message for that. Holy moly, bro. This is mind-bending stuff, bro. This is mind-bending stuff, bro. And I'm going to say this a lot. This is mind-bending stuff, bro. Holy shit. This is now into pure function style. Yep. Transform into a point free style. Point free style. Oh, it's because you fixed this with this. Okay, you're fixing is this. You're fixing is this function with this data point, and by the time that you call this, you say, hey, it's short enough message. So the other may vary here. Oh shit, point free style. Oh crap, that's just mind-bending stuff, bro. Jesus. Oh my god, but these people that sit on the ivory tower from functional programmers, like, what the hell is even this? Okay. Yes. Hell. Jesus, my mind was expanded. Oh, okay. I don't know if this is necessary, you know? I don't know if this is necessary. Sometimes to me it was like, what the French toast is this? A point free technique, man. Holy bro. My point free technique, equational reasoning, and what you're doing is similar when you now fix in the quadrant in 8th grade of the y and g axis. You fix a point there, and then you can compute the other. So in other words, you can create now a line to that in 2 dimensions. Or if you fix one point in a 3 dimension, like say a g, or let's say in an x, okay, let's say in a c, in the c axis, right? Now let's say you fix a point in c axis, so you create now is an area for that. Okay, so you can compute all of the value, but fixing that. Point free. So by looking at the function by its shape, okay, and then, okay, so by looking at the function and its shape, that's why this is something that I get it why there is no a lot of people here, but this is interesting. It is very interesting. It is very, very interesting. In any way, so by fixing a point there, okay, yeah, but by fixing a point there, all right, in any axis, in any dimension, or in other words, by now passing is a function, a specific function that you want to do something, and then now once you call that, you can pass is any arguments there, any checks or predicate or a statement that you want to check along with its arguments. That's something that you can get benefit from that. Holy moly, bro. My question is that my question is, all right, that's good. That's good. Let me now explore the solution is something that I'm quite familiar with. All right, but now some advanced point free techniques.
More advanced techniques. And I want to give you just a couple. This is just a quick glimpse at a couple of these, and we're going to come back to them later in both lectures. So if I defined a couple of utilities, and by the way, I'm not inventing these are ones that you would find in a functional programming library, but let's define one called mod. It's going to do modulus operation. It's doing something which might seem a little bit strange to you. I'm taking the first input mod on line 1, I'm taking y. And then I'm returning a new function called 4x. In other words, that function's purpose is to receive the x. And when that has been provided, when we have provided a y first and then an x, those are 2 separate function calls where we provide 2 inputs one at a time, then what happens is it does x mod y. So we're providing them in a reverse order. That's going to feel a little strange to you, but I'll show you in just a moment why. And then I'm going to do the same thing with an EQ operator. An EQ utility, which takes a y and it takes an x, and then it returns us the equality comparison. These 2 kinds of utilities, which take their inputs individually, rather than passing x, y at the same time, taking them in 2 separate function calls. We already saw a brief example of that. The question that was asked earlier, is this sort of currying? Yes, this is basically a manual form of currying. We'll get to that. But I'm saying I want the y input first and then the x. And I want to make a point about that before we move on. Remember that I said earlier, functional programmers care a lot about the shape of their function. It matters not just what kinds of inputs a function is, but what order they're listed. Because if you list them in a different order, guess what people are going to have to do to use your function every time? Flip it, or use reverse arguments. You make it less ergonomically friendly to use when the inputs are listed in an unnatural order. So it matters what order. And what you're going to see here is actually there's an order that is much more natural, which is yx instead of x. And yx instead of xy equals 1. So that's why I've listed them. Okay, so let's take a look at how we can use this mod and this EQ function to define. Remember, we defined is even in terms of is odd. But what if we wanted to define is odd in a point? Remember, is odd was defined as x mod 2 equals 1. if we have these two utilities in play, couldn't we define is_odd in terms of those two functions? So I'm going to take mod2, mod parenthesis 2. That's going to return me back a function, right? Where the y has been provided, but the x still needs to be provided. And I'm going to call that function mod2, because that function takes any input and mods it with the input. And then I'm going to call eq parenthesis 1 line 13, and that makes an eq1 function, whose job is to take any input value and compare it to the value 1 is equal to 1. Quick little foreshadowing to the stuff we're going to talk about earlier. Do you see that the mod2 function on line 12 is more specific than the general mod function on line 1? The general mod function on line 12 is more specific.
So your points fix that.
The general mod function on line 1 takes two inputs. The mod2 function on line 12 takes one input, because it's got one of them already. It's a more specialized function. Come back to that. Okay? But I've got a mod2 and an eq1. How could I define is_odd in terms of those functions? Well, it's actually pretty straightforward. Take the mod2 and pass in the x, and whatever that returns, pass it into eq1. Now that's not point free yet, but we've made a lot of progress moving from operators to functions. So we're halfway there. If we want a point-free definition in is_odd, this is halfway there. We notice that we have this eq1 and this mod2. They're useful to us, and we can make those with the mod and eq operators that are provided by our favorite library. But we can also notice something. This is yet another future thing we'll talk about in the later in this course, which is the output of the mod2 call is passed directly to the eq1 call. You see that? Which is the output of the mod2 call is passed directly to the eq1 call. You see that? That concept of having one function calls output immediately becomes input to another function. That is a special name in programming. That's called
composition.
Again, throw back to a math class. You may have heard somewhere like that was G or that was G. That's all a mathematical idea. Here we see it up perfect. Take one function's output and make it the input.
And make it the input on the other function.
So how can I use the idea that this is a composition to my advantage to make a point definition? Well, if I had a compose utility, here's my is_odd. If I had a compose utility whose job was to do the routing of one function's output into another function's input. Now line 14, I just defined is_odd as the composition of the eq1 and the mod2.
It's because they have the same shape.
It's doing under the covers. Mod2 is fn1, which is called with whatever value passed into it. That's line 10. So mod2 here is this function. Pass in a value into is_odd, it would come into mod2. Whatever that output is would come into fn2.
We're going to reference to eq1.
eq1 is going to return us a true false, just like we want in is_odd. Okay. How am I able to make that analysis? This is more equational reasoning. That the function composed here is the same shape as is_odd. Look at those two. Look at composed with an fn1 and an fn2. Look at is_odd with an fn1 and an fn2. Look at the input x, input p. Look at the return value and the return value. Those two are interchangeable, which is what lets me know that line 14 is my point free definition. Simply call compose, get back. That's the equational reasoning. And we have one last equational reasoning trick up our sleeve, which is in line 1 and line 2, I defined those intermediary functions, mod2 and eq1. But now I can see that eq1 could be replaced with eq parentheses. And mod2 could be replaced with mod. So my final point free definition looks like line 16. Those pieces are interchangeable because they have this function. And equational reasoning is the heart of being able to do this style. It's actually the heart of a bunch of functional programming, but especially point free stuff. Asking yourself, if I have this function, I need to make this function. What kind of shape change does it do?
What kind of shape change
pretty sure
this
that at some point along
to
the
the
way, we crossed that line for all of you. We're like, oh, I never would have come up with that. At least that's how I was. When I first saw this, I was like, oh, we just went way beyond what I thought was like, oh, I'm tracking with the readability, now I'm lost. And now I will just tell you that having spent time practicing this, and I'm fortunate enough that as a teacher I get to re-explain it and re-show it and
yeah, absolutely, absolutely.
But in being able to practice this, I will tell you, not only can I read line 16 and understand it, line 16 is more readable to me. I've gotten to the point where that familiarity level has switched to where the point-free functional style is actually appropriate. And whenever I see something like line 5, immediately my brain says, that's a composition, you should be using compose then. I didn't get there overnight. It didn't happen in a week. It didn't happen in a month. But over a period of time of practicing these techniques, you become more familiar with those patterns, and they start to jump out at you, just like you see the Legos in the pile, and you say, nope, that's exactly what they're doing. That's the heart of being a functional programmer. Getting used to that, being able to recognize that, and then being able to read lots of stuff like line 16 and have it make sense.
Holy moly, bro.
All right, so we've already hinted at the idea of closure in this course. A couple of times we've already used it.
Holy moly, bro. That'll be all for this video. Take care. Bye bye.